Hey guys, in this lesson we'll be looking at how we can set up our Visual Studio 2022, which is basically all we need for our development environment in .NET. So Visual Studio 2022 is the latest and greatest in development technology from Microsoft. It is the successor to the previous version, Visual Studio 2019. You can get to this page through a simple Google search, or you can use this URL, visualstudio.microsoft.com, and it will lead you to this page. So there's a little write-up about it. It helps you with your productivity. It now supports 64-bit machines. It supports .NET, which is a cross-platform development environment that allows you to do mobile and desktop apps, even though in this particular course we'll be focusing on desktop development. However, it is very capable of supporting not only Windows applications, but mobile and even Linux and Mac environments. It is innovative because the IntelliSense or code hinting is far more powerful than it has ever been. So you'll find that very useful, and you can go ahead and read up more on it via this page. However, to get the installation started, we'll go to download Visual Studio, and we will be using Community. Now, the difference between Community, Professional, and Enterprise, these two offer free trials and they're mostly geared towards professionals. So alongside the license that you'll have to buy for professional or enterprise, you do get additional bits of software and subscriptions to Microsoft technologies. However, as an individual or for educational purposes, then you can use Community, which basically gives you all of the power out of the box that you would probably get in professional and enterprise anyway. So you can proceed with the Community edition, and that will launch a download for an installer. Now, when you launch that installer, you can continue, and I already have Visual Studio 2022 installed. So some of the things that I will be showing might be slightly different for you, but ultimately it will amount to the same end result. So when that installer window launches, you will have the option to go ahead and install Visual Studio 2022. Now, because I already have it installed, I have to go to modify, which is probably where yours would jump to initially or automatically. Now, on the modify screen, this is where we're going to be choosing the workloads. So the workloads basically refers to the sets of features that you want Visual Studio to have and the different development environments that you want it to support. So for console and desktop and anything that is an application like that, you definitely need the .NET desktop development workload. So you can go ahead and tick that one. For web development, you'll definitely need the ASP.NET and web development workload. So at minimum, I would recommend that you tick the ASP.NET and web development as well as the .NET desktop development. However, you may see other workloads that interest you. Those may not be necessary for the purposes of this particular course, but you might be interested in using them in the future. So you can go ahead and tick them. So you'll see that I have Azure development because I do some work with Microsoft Azure. I have Node.js included because I might do some Angular and some TypeScript stuff in the future. And then you'll see others that I don't even have ticked, right? So at minimum, once again, I suggest that you have the ASP.NET and web development as well as the .NET desktop development. Once you tick those two, you'll be able to install them. Now, the size of the download varies based on the number of workloads that you select. So yes, you may be interested in everything and you want to tick them all, but just be mindful that it will take up much more space and take a much longer time to download and install all of them, right? So for now, you can be targeted. You can always relaunch the installer. And if you have installed it already and you want more workloads, then you would be having the same experience I am, where when you launch the installer, you would go to Visual Studio Community 2022 and then go to modify. And then through modify, you'd be able to tick off more and go ahead and install. So if I was interested in mobile development, I would tick that. And then you see here, it's telling me I need 4 gigabytes. Then I would click modify and then it would install after the fact. If I no longer want a workload, right? So if I no longer want Node.js, I can untick it and modify and it will free up that much space because it would remove that pack. So that is really it for installing Visual Studio. Let that go ahead and install, and then I'll see you in the next lesson. Welcome back, guys. In this lesson, we're going to be taking a quick tour of Visual Studio 2022 while we're setting up our first project. All right. So Visual Studio 2022, once it launches, you will get this little window. I am running dark mode, which is why mine looks so cool, but you might be running light or blue, which is something you may have been able to select while you were doing the installation and the initial steps. However, whichever theme you're running, the layout is going to look very similar to this. On the left, we have recent projects. Now you see here that I have collapsed my recent projects, but I have quite a few projects. I just don't want to distract you with anything and make you feel as though yours is not running as smoothly or as well as mine is. But once you start your development activities, Visual Studio will kind of archive them to the left to allow you to quick launch them if you need to. However, we both have the opportunity to get started. So we can clone a repository from an online repo like GitHub or Azure DevOps. We can open an existing project or solution. We can open a local folder, and then we can go ahead and create a new project. We can also continue without code. So I'm going to go ahead and create a new project. Now you have different templates, and these templates are relative to the workloads that you would have selected during installation. So to the left, you have recently used templates. So if you had gone in and experimented already, then you would have these kinds of templates listed to your left, whichever ones you experimented with. If not, it may be empty. That's no problem. To the right, however, is where you have all of the potential templates that you could possibly have based on your workloads once again. You can also search and filter. So you see I have a lot here. I don't know where some of them fall in the list. I can always type in the one that I'm interested in up top, and it will filter this list accordingly. Now, when selecting your template, you have a number of options. You have the language that you want the template to be in. This is a C# course, so we're going to be focusing on C# based templates. And then we have all platforms, or Android or Azure. You can filter according to that. You can also filter according to the project types. So we're doing console programming in this particular module. I could easily say C# and console, and then it would only produce me the templates that are conducive to these two options. Otherwise, without these filters, of course, I can scroll through. Now, if you don't find the template that you're looking for, let's say you get this far and you're trying to find C# console and it's not there, that means you probably didn't install the workload. So you can always go to the end of the list and you can install more tools and features, which will actually just relaunch the installer that allowed you to select your workloads. You select the missing one, which will be for desktop development, allow Visual Studio to modify itself, and then the next time you come here, you should be fine. So let us get started with a C# console app. So notice you have C# console app, you also have VB console app, so be very careful to take note of the language that is being used. We're not using Visual Basic, so if you want to be sure, you choose C#. And then when I did console, you would have seen two different options. You'd have seen one for .NET Framework versus the .NET Core. So we're actually going to be focusing on .NET Core because .NET Framework is older technology, and that's when it was Windows only. Since .NET Core, .NET has become open source. So we want to focus on the more recent advancements with .NET development, and we'll be using .NET Core. So we'll choose the console app that can run on .NET Core, that can run across all the platforms. Remember, I did mention that it is now cross-platform. So we'll select that, just double click it, and then we'll be faced with the the wizard option to put in our project name, choose a location, and select a solution name. So I'm going to choose for the project name, very simple, Hello World. That is usually like the first program that anybody ever writes in any programming language. Hello World. Notice that by changing the project name, it automatically changes the solution name, but I don't necessarily want the solution to have the same name as the project. So I'm going to choose this one. I'm going to name this console programming. Now, the relevance of this is that the solution to a solution to a problem, right? When you're developing an application, you're developing a solution to a problem. Solution, right? The solution may have a name, but it has different projects, which is something that we will be doing. So we're going to have one solution that has many projects. So that is why I'm naming them differently, even though by default it would have tried to give them the same name. I'm showing you that you don't necessarily have to, because there are times when you have a solution and then you have different projects with different names under the same solution. So project name, hello world. If you want to change your location, you may do that, but I'm going to leave my default location. And then the solution name is console programming. Then I'm going to hit next. It is optional to place the solution and the project in the same directory. I'll leave that unticked. So we hit next. And then we have to choose the framework version that we're interested in. So we have .NET Core 2.1, which it is very clearly telling you is out of support. So my suggestion is don't start there. And if you're already doing some development and you have a .NET Core 2.1 application, I would suggest that you try to upgrade it as soon as possible, but that is out of support. .NET Core 3.1, that will be in support until I think December 2022. This .NET 5 was like an intermediary between 3.1 and 6, and it is going out of support in about May of the same year. But .NET 6 has long-term support, and that will be in use until the 2024 or thereabout. It will be in use for a few years. So I would suggest you just start with .NET 6, as that has the longest bit of longevity out of all of these versions. That being said, however, with just a few tweaks between each version of the .NET frameworks, each version of C# has incrementally improved, and most of what you can do in 3.1 is also possible in .NET 6, but then .NET 6 has also refined certain processes and the code layouts that are not visible in previous versions. So we're going to do a quick comparison just to make sure that you can appreciate the difference and the nuances between the versions. So I'm going to start off with .NET 6, and then we can go ahead and hit create. And that is the end result of us creating a project. 2 files, well, 1 file really in the Solution Explorer, and a file called program.cs with 1 line of code, or a comment and 1 line of code. So I'm going to pause from this point. We just looked at how we create a project. It's something we're going to do a lot more going forward. So don't worry if you didn't, commit all of the steps to memory. That was a lot of information, but we'll be doing it again. For now, I'm going to pause, and when we come back, we're going to take a tour of Visual Studio, this IDE, what it is capable of, and how it will help us with our development pursuits. All right, so in this lesson, we're taking a look at Visual Studio 2022, the user interface, how everything is connected, how it works, how we use it in general. First of all, you'll notice that my Solution Explorer is to the left. Yours by default is probably to the right. So you can actually take these, toolbars and move them all around if you have a different vision for how Visual Studio is laid out for you. So personally, I like to have the Solution Explorer to the left. So I actually can just drag it over and dock it. You'll notice that these little squares appear. When you drop it in the square, it will show you where it will appear should you release your pointing device. So if you drop it in the center, then it becomes another tab. I don't necessarily want to be writing code and then I have to tab over here to change the file and then come back. I don't like that. So I like to have it kind of to the side, and in my case, to the left-hand side. And then I don't want it so wide either. I can always make it smaller or larger accordingly, right? So of course, it affects how much real estate you have for your code editor section. So you can experiment with that. You'll also see other toolbars on my screen that you may not necessarily have. And any toolbar that you're interested in, you can always go to view and you can see it. So if you accidentally close your Solution Explorer, then you can always go to view and you'll see your Solution Explorer. You click it, it reappears. All right. You can pin it and unpin it or hide it. So if I want it hidden, but then when I hover or click one time, it appears and then I use it and then I continue doing what I want to do. That's another way to keep it on the screen, so to speak, but have more real estate for writing your code. So I'm going to kind of have it docked permanently because I have a big enough screen that I can use it, but you may not necessarily have that, which is why I'm showing you how you can auto hide also. So I'm just going to focus on the things that are absolutely necessary for us to get through console programming, at least for now. As we go along, we'll see more and more things. Now, Visual Studio has different themes, like I would have mentioned. You see here I'm using the dark theme. You can always go to Tools, Theme, and choose the theme that you like the most, or you can get more themes. And when you get to a certain level, you can even design your own themes. So if you started off with the light theme, then your Visual Studio is probably going to look more like this. All right. I don't like that. That is harsh on my eyes. If you chose blue, then I think it just changes the many items, right? So this is like the classic Visual Studio look from Visual Studio 2005 and 2008 days. It kind of looked like this, or more like 2012 actually. And then you can also, like I said, you can choose other ones. I got one off the marketplace called Nordic that kind of has this grayish bluish hue. I'm just showing you your options, right? Once again, you can always get more themes. If you use system setting, my system is set to dark theme in my Windows. So it's just inheriting that from my Windows machine, all right? So once you're comfortable with how your Visual Studio looks, then you can proceed. Now, in terms of color coding, this is our editor, right? And it's really just a text editor. So if you've ever written any code before, then it's a text editor. If you've never written code before and this is your first coding course, that's no problem. That is not a problem. This is just a text editor. Think of it like Notepad, right? So the only difference though is that we're going to be writing specific syntax to accomplish specific things. So the color coding, or you'll notice that certain bits of code have different colors and they really signify their role in the whole experience writing code. So in the dark theme, at least, you'll notice that console has that kind of teal look. I'm kind of colorblind, so forgive me if my colors are off, but that console has that teal look. So console is what we call a class. That is how it's going to color code anything that is a class, right? Then you'll notice right line is white. So functions, this is a function or a method that is going to be white. And methods are usually characterized by open and close parentheses, right? And then every line, or 90% of the lines that we will write, at least, end with a semicolon. So that semicolon is very, very important. All right. Now, notice if I missed off that semicolon or I misspell something and Visual Studio cannot figure out what I am referring to, it will give you that red squiggly line. And if you use Microsoft Word, then that is something you're familiar with, right? So this is going to indicate that there is some error with the code that I've written because the syntax has to meet very specific rules in order to be accepted by our editor. So once the editor detects that there is something wrong with the syntax or what we have written, it is going to give us those little red lines. So sometimes these lines are the errors. If you hover over the line, it will tell you what the error is. Sometimes it cannot tell you what the error is outrightly, right? So here it can tell me that the semicolon is expected. Okay, if I put the semicolon, that one goes away. But then this one, it doesn't know what right lie is. It knows right line, but it might not be able to determine that right lie is just a misspelled version of right line. So that is where it may fail you. So you can always hover and then you can click on this little light bulb, which will try to give you some suggestions. So here, Visual Studio, especially in 2022, has become so intelligent that it can actually contextually see this time that it is probably just a typo. Change right lie to right line. Okay, if I click that, it will make the correction for me, and then that line goes away. So that is how Visual Studio is actively helping you to write better code. So if I made a bigger mistake than that though, like something like this, right? Now I don't know what it can do in this situation to help me, because it's just going to say this does not exist. It doesn't know what this is. It's suggesting an error. This one is just saying this is a variable that was never used. There's no variable there with that name, etc. So I'm just showing you that there are some errors that it can help you with, and sometimes it's just not going to know what to do. So from time to time, you may need to end up Googling, well, what your error is, or you just erase everything and try to write it again from scratch and see how Visual Studio can help you. Now, another thing that I did not highlight was the fact that we're getting these code hinting. So by going to the next line, Visual Studio is making an assumption that maybe I want to do another right line. So by pressing tab, I can actually accept that grayed out block of text as what I intend to do, right? So if I wanted to console, but this time, so you see I made a mistake, console dot, and then you see here when you do a dot, you'll actually get this thing called IntelliSense suggesting potential methods or properties that you can use to complete what you're doing, right? So sometimes, I mean, you're not going to sit down and memorize every single method to just write it. There are times when you just won't. So once you do the dot, Visual Studio is going to make suggestions to say, maybe you want buffer width, maybe you want a read line, and then you start typing and it's going to filter them and say, yes, I want read line. And then you can use that, right? Another thing to notice on this point is that if you didn't choose a suggestion, something happened and you clicked away and then the suggestions went away, right? The way you get them back is control and space. So from the full stop, if you're typing, it will suggest it to you. But let's say you pressed escape or you clicked away and you don't even have that autocomplete line available to you. You want to know what your options are, you can actually do control space and then you will see your options. And I'm going to be honest, I've been doing this for years and there are times when I don't know what needs to come next. There are times when I control space and I scroll through until something looks like what I'm looking for, right? And I'm sure a lot of experienced C# developers will tell you the same thing. So I'm just saying that to say there's no shame in getting this far and not necessarily being sure what you want to do next. That's why Visual Studio is designed this way, to give you that IntelliSense to assist you. So you can be scrolling and then you say, I really want to write something, or I want to take input. I want to read something, and you see read, read key, read line. Maybe let's try read line. And then you can use your tab and then autocomplete that, right? So I mean, I'm not able to show you every single nuance and everything about Visual Studio in a 15-minute video. There are things that you will just pick up as you go along, and as we write code together, I will be pointing certain things out. I will always show you keyboard shortcuts. So, like writing a comment in C# would be / or / and then */ and this one allows you to do multiple lines of comments, right? So if you needed to write a paragraph, you would use this one. If you wanted just one line of comments, you'd use that one, because the next line wouldn't be commented, right? So a keyboard shortcut for that would be Control K and C. So if you have a line of code that you no longer, or you don't want it to execute, you want to comment it out, you hold down on Control, you press K, and then you press C while still holding down on Control. If you want to uncomment it, it would be Control K U. So you're holding down on Control and you press letters K and C to comment, and then to uncomment, holding down on Control, you press K and U. So those are little things that I'm going to be showing you. If you want to duplicate this line, you do Control and D, right? Or Control CV, right? Which is really copy and paste, but you notice I didn't highlight the line and say copy then paste. I just had the cursor there and then holding down Control, pressed C and then V, and then it just duplicated it, right? So Control D may work for you based on your development settings. It may not. I've had persons say it does not work for them, but Control CV generally works in that way. So for the final bit of this tour, I'm going to show you how you execute your application. So at this point, we have some code that is supposed to print to a console, or we're doing console programming, right? So console programming, because at the most basic level in most languages that are designed for desktop, you're going to have a console. So when we say console, we mean like command line. If you've ever done command line on your machine, whether it's Windows, Linux, or Mac, it would look something like this. This is your console. So when we say console.writeLine, we're actually calling the underlying functionality that gives us this command prompt window and saying that I want to print whatever text I have outlined here to this window. So when you're going to be testing your application in Visual Studio, you have the option to either run it, and this is using debugging, run it without debugging, or the keyboard shortcuts would be F5 to mimic debugging and Control plus F5 to mimic no debugging. Later on, we'll look at what debugging means, right? But the general net effect is that when you press these, either one of these play buttons, it should execute the code that you have written, and it should pop up on screen showing you what the outcome of your code is. Whether or not it's desirable now is where you programming comes in. You make your modifications and you get it to the point you want it to be. But to run it, you're just going to press the start button, and then it starts debugging. So you see the output window is coming up and it's giving you all sorts of stats. And then you get that console window that looks just like the command prompt. And then you get your line, hello world. Then it's telling you that the code executed from this location. And notice that's an executable file. All right, so any installer, any application you run is usually an executable file. And then it says it will automatically close. Well, they're giving you the option to automatically close it, but we don't necessarily want that. We can just press any key to close this window. So if I press enter, it will just close the window and return us to Visual Studio. And that's really it. So that was a very simple Hello World application given to us by our Visual Studio. So yes, the project was called Hello World, but the code was generated for us, not because the project was called that, right? Before I leave though, let me give you a little tour of the Solution Explorer, even though I'm going to expand on this a bit more. Here is the name of the solution. So remember I said that we had a solution different from project or projects. So we have the solution called console programming, and then we have the first project called Hello World, which one click will reveal an XML file that allows us to change certain things. We're not getting into that right now. And then we have dependencies. You don't have to worry about that right now. And then we have one file called program.cs, which is our class file housing our code. We can have multiple files, of course, in a project, which we will be looking at as we go along. So that's really it for the tour, the general tour of Visual Studio, what it brings to the table and how it will help you to write clean and wonderfully executable code. When we come back, we're going to look at the difference between a .NET 6 project and the previous versions of .NET. All right, guys, so we've been learning C#. We've been getting familiar with Visual Studio. Let's write a real program, shall we? So I'm going to create a new project for this new program. I'm going to right-click our solution, go to Add, New Project, and then we want another C# console application project. I'm going to call this one Input Output. So Input Output, click Next. We know that we need to work with .NET 6, and then we create. Now, of course, if you were using Visual Studio Code, that means you'd create a new folder, do a new .NET console program, and then you would be at the same stage as we are. So for this application, what we're going to do is, and I'll just write comments. One, declare what we call a variable. Two, we're going to allow user input and store in variable. And then we're going to print contents of variable or the user's input. All right. So just visualize it. Anytime you're using an application, whether it's web or desktop, you usually, as the user, would put in data, press a button like save or something, and then at a later point, you'd either see it represented to you by the program or saved until a later point. We're not quite at the part where we're going to save it until tomorrow, but for now, we can at least see how it is that we receive input from the user and then send it back. So typically, computers do three things. They accept input, they do a process, and then they produce an output. Those are the three processes of any computer. Take input, process it, and then send back output. The process, of course, could be as complicated as a math equation. It could be something else. But whatever we do in between taking the input and producing an output is called a process. All right. So let us look at declaring a variable. Now, C# has different data types. A data type is pretty much like an adjective that describes the variable, and it defines or tells the variable what kind of data it can store. So data types in C# can be, let me just do this, data types can be, and are not necessarily limited to, I'm just showing some of the basic ones. That would be string. That would be like words and numbers, like a license plate, like a name or a license plate number. That's why I said names and numbers. Anything that once it contains letters, it can contain numbers, it can contain special characters, but that's what we call a string. We also have numerical data types like integer, which would be more like whole numbers. We have double, which would be more like decimals. And then you actually have double/float, right? And in more recent C# versions, you actually have decimal as a data type, but I'll just stick to the traditional ones just in case we're on different versions. So you have integers, you have double, you have float. You also have like char. Char represents one character, right? So it could be a letter. It could be, it's just one. So that's the example of it. The letter A or the number 7, right? It's just one thing at a time, right? It could be a special character. Those are all examples of chars, right? Let me get my spelling right. Strings would be like blocks of text. So those blocks of text would use the double quotation mark. Notice the char uses a single quotation mark. So in an earlier example, you would have seen me use my name. And in the default example, you would see hello world. That is a string. All right. So you have different data types, and we'll be going through others. I'm just trying not to give you an information overload, but these are typical examples of different data types. So like I said, it's like an adjective describing what the variable can store. So the variable is the actual storage point. So to declare a variable, I have to give it the data type, and then I give it a name. So if I'm going to want the user to enter their name, then I would call the variable name. So the thing is that you want to always be as descriptive with your variable name as possible. You don't want to say string X. What is X? Right? When you have to describe X to somebody else looking at your code, or even try to remember what X was used for two weeks later, you will not remember. When you say something like name, it is clear. If you want age, you would probably want to use integer and say age, right? That is clear. If it is something that is more than like more than one word, like maybe full name, you'd want to say something like full name. Now notice how I wrote this. One, there are no spaces. Spaces are illegal in variable names. You can use special characters as far as an underscore. That's the only special character that is allowed. You cannot use a hyphen. You cannot use anything else but an underscore. Put it that way. Some people like to use underscores. Personally, I don't. I don't like to use them. They are legal. There's nothing wrong with them. So if you want to use them, no problem. I, however, rely on what we call camel casing, which is when you make the first letter common and then you capitalize every other word. So you see, here's an example: camel case, right? So like when we named our projects, we would have used Pascal case. So if I said hello world as a variable and I capitalize the H and the W, then this would be Pascal casing. All right, so we capitalize the first letter as well as every other first letter of every word in there. So generally speaking, when you name your variables, you want to use camel casing because it improves readability, and anybody who looks at it can tell that this is a variable designed to store the full name of whatever, right? So that's why naming is very, very important. So that is our very simple variable. All right. Now, that was number one, declare a variable. We looked at the different data type options. Based on the information that we want to get, string is the best data type for that information, right? Now we need to allow them to input that variable. So far we know how to output because console.writeLine is what allows us to output. However, we need to input. So we don't want to write, we want to. If you said read, then you're on the right track. So we want console dot read line. See that? So when we say console dot read line, the console will actually pause and wait for input because it's now reading something as opposed to write line where it's going to print out something. All right. Now, of course, when we allow the user to insert whatever via the read line, we need to store it somewhere. Right, because when they press enter, after they type it in and press enter, the information is sent back to the program. But where is the information going? That is why we have the variable. So the variable here with the green line is complaining that it is declared but never used. It's never used because we're not using it to do anything. We just have it there. So the presence of it is important, sure, but it's not doing anything. So we want to say, when you receive input from the console, please store it inside of this variable. So I'm going to say full name. You will get your value from whatever comes in through the console. All right. So there are a number of ways to write this code. All right. I'm just trying to show you the simplest way so you can get on your feet and start working. One, make sure the variable exists. Two, assign the value to the variable. So this is called an assignment, where whatever is on the right goes into whatever is on the left. So an example of an assignment, we did an example earlier. I could say string full name. I'm assigning you the default value of maybe an empty string, or you should have the default value of my name. All I'm doing is saying create a variable and assign this value to said variable. If I do not put the assignment, then the variable will exist with nothing in it. So it's what we're going to call null, which is just like a space saver, right? So there's nothing inside there until we do an assignment like this. All right. So after we assign the value that the user enters into our full name, then I can print console.writeLine. And then Visual Studio figures that I would like to print what is in full name. So we've seen console.writeLine a lot up until now. We can print a literal value like we did hello world, right? Or in this case, I don't want to print the static string because the user didn't enter hello world. I don't know what the user entered. Whatever they entered is stored in full name. That is what I want to print. So instead of writing out all these quotation marks and that block of string, I'm going to print the contents of my string variable back to the console. All right. So at the end of this application, once again, we are creating a space in memory. A variable is basically a space in memory, a storage space in memory for the time an application is running. So as soon as the application stops running, that variable no longer exists. When you start it up, it creates it, then it waits for input, then it assigns said input to said variable, and then we print it. So let us take that for a spin. Now, you'll notice that the play button up top still says hello world. That means if we press play, it's still going to run the program.cs in hello world. We don't want it to run hello world. We want it to run our input output program. So we can actually change this by changing this drop down list and choosing the program that we want or the project that we want to run, which would be input output. You'll also notice that when you change it, the project that is being focused on at that point is the one that gets the bold letters in the name, right? So if I change it back to hello world is bold. If I change it to input output is bold. Another way to do that is to right click the project itself and click set as startup project. So that does the same thing that the drop down list up top here does, right? So if I want input output, right click, set as startup project, and it will now focus on input output, and the play button will show the same thing. All right. So when I press the play button, notice that the console is on the screen and it's just blinking. Okay. Why is it just blinking? It's not printing anything. It's not proceeding. One, it created our variable, sure, but it's also waiting on input, right? So if I put my name and then press enter, it will proceed to print to the console, and then you notice it stopped because that's all I told it to do. Wait for input, print, and then you're done. So this second line is what it is printing. This is what I entered. Now, this is not very intuitive. I'm sure you're saying that it's not very intuitive because it just paused for input. I wrote the application, so I know what the input is that it is pausing and waiting for, right? Do you, if you were to pick up this application for yourself without my guidance, would you actually know that this is what it wanted? You wouldn't. And I wouldn't expect any user really to know that. So what you would want to do for this kind of application, just like any other application, if you're filling out a form, they usually tell you what they want in the text box or for that particular input so that you, the user, know what you're doing. So you always want your user to know what they need to do. So you can always print out your own messages to screen. So here I'm going to say console.writeLine, and I'm going to give you the instruction, enter your full name. And I'll just put a little colon there. Of course, this is what is being printed. So this is a literal string being printed to the screen. So you want it to look nice and presentable. Nice set of instructions. And then it will pause for input. All right. And then what is being printed? I don't know what's being printed. So I could say something like console.writeLine, your full name is, and then we print back to screen whatever the user entered. All right. So these are little things that enhance the way your application looks. And you do have console.write versus console.writeLine. So console.write is going to print it in one line, whereas console.writeLine is going to move it to the next line automatically, right? So let us try this one. So go ahead and run. So you see here, now we're saying enter your full name, and because we did the right line, it automatically went to the next line to wait for input. So I'm going to say my name, then when I press enter, your full name is, and then it printed it in one line because I said write. So if I wanted the prompt in one line, I would just say write instead of write line. And well, write line automatically breaks to the next line. And that's pretty much it. All right, you see, it's not that hard at all. Once again, sequence matters. Create the variable, print, and ask the person for input, then wait for input, and then you can print out whatever afterwards. All right, so that's a simple input output. Now, one quick refactor that I would like to show you to this is that when you are asking for data to go into the variable, it is perfectly fine to actually just define the variable and assign it at the same time. Of course, you can't have two variable assignments on the screen. So if you create the variable before, you can't do this a second time. But here, what I'm saying is create a variable called full name and give it whatever comes in from the user. So that's actually fewer lines of code. So sometimes it's worth creating a program that uses fewer lines of code. Sometimes for readability, you want it as explicit. So I'm going to leave it like that for your consumption. Create the variable, allow the user to enter, store it in the variable, and then print the contents of the input. All right, guys. So in this lesson, I want to discuss application debugging techniques. Now, debugging has to do with finding errors in your code. At this point, I have a bunch of other projects that we will be going through one by one later on. So don't get caught up on the fact that I have many projects and you don't. Let us focus on the project that we just completed, which was looking at variables and data types. And I want to show you how we can try to find errors in the code as we go along, right? So we have different kinds of errors that will appear in our code. The easiest one to spot is a syntax error. Syntax error could be as easy as a typo, right? So you would have seen that I wrote a few wrong lines sometimes. So if I wrote console instead of console, then the syntax error would be apparent through the presence of the red line. We've seen that before. You'll also notice that Visual Studio would kind of highlight the line to your right, and you see that little red square appear, showing that there's an error on that line. You'd also see that you have that little X down here, and error list would be populated. So there are so many indicators as to the fact that you have an error in your code when it is a syntax error that it's hard to not notice. Now, let us say peradventure you didn't notice it and you tried to execute. So I'm going to change my startup project here, and then I tried to execute it. So I didn't notice that I had a syntax error and I tried to run. Then I'm going to end up with an error like this. So when you run, you have two options. You have run with debugging and run without debugging. Running without debugging means that it's just going to build, make sure everything is okay, and then try to launch the program. Run with debugging means that it's going to run, but be mindful of the fact that you might want to track what's happening. So we'll look at that in a few. However, neither option will work when you have a syntax error. So when you get that kind of error message saying that there was an error with your build, do you want to continue with the last successful build? You don't want to continue with the last successful build. It means that you're going to go back to the good version of the code, which would defeat the purpose of writing new code that you're about to test. So you want to say no, and then you want to give some attention to your error list so it can show you where your errors are. So just by double clicking here in the error list, it will actually jump to that line with the errors. All right. So whether you're going to fix it, comment it, or whatever you're going to do, just remove the syntax errors. So those are the easiest errors to detect. Now, the more difficult type of error to detect is a logical error. So a logic error can be because you didn't write the code in a particular way. You did something before, you should have done something else. Remember that we have sequence, we have repetition, and then we have decisions, right? So if your sequence wasn't correct, then you might not get the desired result. If you made a bad decision, meaning you wrote your if statement condition incorrectly, then you may get a bad result. There are also your for loop, etc. There are a number of things that can throw out the logic. So those are logical errors, which really manifest themselves during runtime. So one of the ways that you can use to track values that are being assigned is by setting what we call breakpoints. So a breakpoint is let's say a marker at a line of code that tells the compiler that while you're executing all the code, when you hit this line, I want you to pause. All right, let that register for a bit. So to get a breakpoint, if you look to the left of the line numbers, so you have the editor, then you have your line numbers, which when you click, it highlights the entire line. So you'll see me doing that a lot, right? To just get the entire line, you just click that line number. But then to the farther left, you'll see that the cursor inverts again. So here the cursor looks normal, right? Just a regular pointer. And then when I go over to the line numbers, it becomes, you know, kind of pointing inverted to the next direction. And then it goes back to normal over here. And then you see those little white dots appear on the lines of code. When you click where that dot appears, it turns red. Now the red dot signifies a breakpoint, and that entire line turns red, right? So you can have multiple breakpoints throughout your code. See that? To deactivate the breakpoint, you just click it again. All right? So click to turn on or turn off. Now, when you are running in debug mode, meaning you press this bigger play button or you hit F5 on your keyboard, it will run and be mindful of the fact that there might be a breakpoint. So when it hits that breakpoint, it's going to pause. When it pauses, it allows you to interact with the variables and other bits of code that would have preceded it, right? If you run without debugging, then it will just run. It won't care about the breakpoints. So let us run with debugging and look at that experience. So here you see it saying enter name, right? So that we know that we're at line 12. That's where it's waiting on the name to go in. So I'm going to put in my name. Press enter, then it goes over and asks for the age. So you know that it's now at line 15. It's waiting on the age. So put in age and then look at that. So it printed the prompt for line 17, but it can't go any further because of the breakpoint that we had put at line 18. So now the application is actually stuck. No matter what I do, I'm actually pressing keys right now. No matter what I do, I cannot move forward because the compiler won't allow me to. All right. So at this point, if I hover over these previous variables, I can actually see what values went in. I can see that full name currently has the value of Trevoir Williams. Age currently has the value of 25, and it's waiting on salary to get its value. And salary currently has the value of 0. Gender has the value of 0/0. That was the min value. And working by default has the value false. See that? Just by hovering over them, I can see that. I can also go down here where some of the additional toolbars are, and I can bring up a watch. So a watch, oh, that's tiny. But the watch section allows me to put in a variable. So I can watch the gender variable, and it will show me what its value is. I can watch full name, right? And it will show me what its value is. And I can also watch salary. So let me watch salary. Right now, salary has a value of 0. Right? But then if I press F10 on my keyboard or F11, and I have to make sure to press F11 because F10 will actually stop the recording for me. The difference between F10 and F11 is that F10 will skip over a method, whereas F11 will bring you into the method. Later on, when we're writing code together, we will see that working, right? But for now, F10 or 11 is fine. So if I press F11, it will move on from that breakpoint, and all the numbers, these are all the numbers I was putting in earlier. But now it's actually at line 18, waiting for me to enter something, and press enter. So if I put 800, let me erase this and just put a sensible number, and then press enter, it will move on to the next line. So you see, when it hits the line, it changes it to yellow. So when it hit the breakpoint, it was yellow. When it moved to the next line, it's now showing me that I'm at the next line, right? If I go to the watch is now showing me that the salary is no longer 0. It's now 8,000 because that's what I entered, right? Now, at this point, I have a few options because it's still waiting for me to go line by line. So I can continue to do F11 or F10 until the end, which, I mean, for a small program like this wouldn't be a big deal. But sometimes you really just wanted to evaluate what happens at a particular line. After that particular line, you can let it continue. So to let it continue, you just press F5 or click continue up top. And once you do that, it will just continue with the execution of the code as usual, right? So here I can put in M, and you see it's not pausing and asking me for anything, and then it continues to the end of the execution. All right. So once again, this breakpoint allows me to pause the application in its tracks, and I can take a look at the variables. Maybe whatever was being set was incorrect. Maybe the salary value was wrong because the calculation I had was wrong. This helps you to pause your application, take a look at the values that are coming across, and then you can determine that, okay, maybe I need to tweak this or modify that as you go along. And then it helps you to move forward, right? So here with salary, I just disabled the checkpoint or the breakpoint rather by clicking the red dot and clicking it off. And you can have multiple. The point is that each time you hit continue, it will go as far as the next breakpoint in the line in that order. So even if I enter the salary and then we went here and then I pressed continue when it hits line 20, it would continue, 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 and then it would do everything up until the next breakpoint where it pauses and waits for me, the developer, to either evaluate what's happening and then continue or go line by line. So that's some guidance as to debugging in your application. This will come in handy when you end up with errors. Maybe your logic is not as well thought out as you would like. And that happens. We're all human, right? Sometimes we don't get it right the first time, which is why these tools exist to help us to refine what we're doing. All right, guys, so in our last application, we took a quick look at how we can declare variables. We took a brief overview of the different data types that these variables can have, and then we looked how to accept and print out information from the user. Now we're going to build on both of these concepts as we look at variables and their data types. Once again, if you closed Visual Studio and you need to relaunch it, you can always just if you close Visual Studio and need to relaunch the project, you can always just relaunch Visual Studio Code 2022. You can look for the recent application or project that you've been working on, or go to open a project or solution, browse to where you would have set the project location to be, find it, and then launch that solution file. You can also do this step from your Explorer itself. So let us proceed. We're going to create a new project. So I'm just clicking on the solution, going to new project, console app, and then this one is going to be variables and data types. Bearing in mind our very strict naming suggestions, right? No spaces, no special characters, and Pascal casing. So we do all of that, hit next, we're using .NET 6, and then we can create. Now in our brand new program.cs file, I want us to look at the different variables that we can use, right? So, and we're using practical examples. So I'm going to be saying variable, declarations, and types. All right. In this application, we're going to create an actual kind of form, data input form for our user. So we want name, age, maybe salary, their gender, and if they're working or not. All right. Let's do all of those. And in doing so, we'll explore how we convert data types between what is input and what is needed based on the data type that we selected for the variable, and how we can print everything out at the end of it. So we already did an example with the full name. So here I can say string full name is equal to, you generally want to stay away from nulls, right? So null meaning that I just say string full name. There's a variable called full name. Leave it be. You generally want to stay away from that. It will work, but when you build bigger applications, you want to stay away from that. So you generally want to give it like a default value. So here is a built-in default called string.empty. Sometimes you may end up seeing persons do this, but this is what you call a magic string. And it's usually discouraged because you could make a simple mistake and not realize, and it would be very hard to figure it out later on. So when you do string.empty, you let C# set the value for you, and it would be much easier to maintain and track down, right? Let's say age. So I want the age. I'm going to use an integer because people generally would be 20, 21, not necessarily 21.8 years old, right? So I would want an integer instead of a double or a float because I'm not expecting a decimal for this. You can also assign this one a default value. I'll just set 0. There are defaults here, but you would end up being int.max or int.min, which would be on either scale of billions, right? So int.min is minus 2 billion or 2 trillion or something like that. And int.max is positive that same number. So here I'm just going to set that default age to 0. All right, maybe 1. Maybe a default age of 1 makes more sense, right? But hey. Next up, salary. Now, salary, you could expect a decimal point because salary represents money, right? So you could use double, right? And then if you want to make it default, you could say 0.0, 0.0, that's your default, right? You could probably also say float because that also takes decimal numbers, except the default value has to look a bit different. So you'd have to say something like that, 0.0f, right? Just to show you, I'm just showing you the nuances with the different data types. But this is also a decimal place. It's just saying that you have to put on the F to represent that it's a float and not just a regular double. You could also use decimal. And if I'm not mistaken, decimal, you would just say like 0.0, right? And you'd have to put on a suffix M. There we go, right? So once again, just showing you the different options, different nuances, right? So I'm going to keep it simple though. Double is good enough. And I can just say the double is 0. It will know that it's a decimal, so 0 is the same as 0.0, right? Gender. Now, I would probably want the user to enter M for male, F for female, and then you'd want to use a character for that. So I would say char, and notice I just accidentally wrote a capital C. Capital C char is different from common C char, right? Similar, but different purposes. So you always want them to be lowercase when you're defining your variable types, right? So char and gender. And I can initialize this one too. I don't think that there's a char.empty, right? But you do have min and max value, and you have a number of other operations there, right? I'm not going to go through all these operations just yet, right? So here I'll just say, give me the min value for the char. And then it's asking for birthday. I don't want birthday this time. I want Boolean. And are you working? So Boolean here represents true or false, right? You either are or you aren't. You're either on or off. Binary, 1 or 0. So bool represents that binary decision, that binary value, 1 or 0, true or false. So you're either working or you're not working. So here, I'm just going to default it to false. So you'll notice that false and true are actually keywords. You can tell that from their color coding and the fact that Visual Studio is actually suggesting those values in the IntelliSense for me. So even with a bool, if I don't assign a value, it will default to false. So that's something that you can bear in mind. If you don't give it a value, its default is false. If you don't give integers and doubles values, their defaults will be 0. Yeah, char, that will default to null, just the same way that the string will default to null. So as you practice and you get more comfortable, you'll know these things. I'm pointing them out because I've been doing this for years. So I can exude this wisdom because of experience, but I'm sharing the wisdom so that you can have it in the back of your mind when you're going through an experience, right? So those are the variables that we want to work with for this exercise. Now, what I want to do is prompt the user to enter each one of these, and then I want to store it in the variables, right? So let's start off with name, because we've done that before. So I'm going to say console.writeLine, and I'm going to say, please enter your name. And I'm going to do console.write. So I want it all to print in one line, and then it's going to pause for input afterwards. Semicolon. And then I'm going to say that the full name is going to be equal to whatever the user inputs, which would be console.readline. So remember that last time we looked at the fact that you just have to assign it there, right? Now, I did mention you could define the variable here and do everything one time. For readability purposes, sometimes it's good to just get all of your variables defined up top and then you use them later on. So at least you know what you need, then you can write code around what you've already worked out. So it's not necessarily one is better than the other. It's just, I'm just suggesting this kind of workflow so you can get your mind in order and have your strategy for your application ready for when you need it, right? So this section, I'm just prompting user for input. All right. Now I'm going to basically just copy and paste this, and I'm going to say, please enter your age. Sometimes you have to work smarter and not harder. You already have the console.writeline. You know that you need to assign the variable. All I'm going to do is copy and paste, change the text that I need to change, and then use the appropriate variable. So here I'm saying, give me the age. Oh, wow. Now I have a red line. What is this red line saying? It says it represents, sorry, let me hover over this again. Okay, so sometimes when you hover over it, you're not going to see the error. Oh, there it is down at the end. Cannot implicitly convert type string to int. Another place you can go to see the error details would be error list, which is usually down at the bottom part of your interface. Cannot implicitly convert type string to int. And if you don't see it there, you can always go to view and you'll see error list and you click it and it will appear. So here it is saying that I have an integer called age, but console.readline is actually accepting a string from the user, meaning no matter what I type in through the console, it will always see it as a string. So remember earlier when I discussed the different data types, I had said that the string is actually capable of storing words, numbers, special characters, anything that is on your keyboard is actually going to be processed as just one big block of text. So when we put in the console input, it is not assuming that because you put the numeral 1 that you want an integer, or you put one letter you want a character, or you wrote the word true, you meant a boolean. It will always be assuming, right, that you are entering a string. So if you want this string to be stored as something else, we have to do a manual conversion. So to convert from string to int, you have the option to use convert, which is just another built-in class. And I can say convert dot, and I can now say to int32. So I want to convert to int32. This is a method, so I have to open my parenthesis, and then notice it's saying I have to pass in that string value that I intend to convert. What am I converting? That string input from the user. So I'm going to say convert to int32, whatever input came in from the user. And then every time I open a brace or a parenthesis, I need to make sure I close it. So this one, this one is open and closed for the read line, but I need to close the to int32. There we go. That gets rid of all the errors. I hope that was clear. If it wasn't clear, it's about to get much clearer. So now we move on to salary. So I'm just copying and pasting again, and then I'm going to say, please enter your salary. Then I'm going to be assigning salary. Now this is converting to int32. I don't necessarily want to int32 in salary because salary is a double. It is not an integer. So I don't want, if the person put in that they make $210.05, I don't want just $210. I want the 5 cents also. So I need the decimal place. Well, guess what? I can convert from string to double or to decimal. We're using double. So I'll say to double. There we go. All right. So string input from user, convert it to double, store it inside of salary. Coming along nicely, right? So I'm just going to go ahead and duplicate these lines for gender and working, and then we can figure them out. So gender, please enter the gender, and then please enter if you are working or not. Now notice red lines again. This one says gender, and this one says working, let me say working status. Or let me rephrase that. Are you working? Are you working? Right? So for the gender, we're using a char. I now need to tell the user what legitimate inputs are or what the inputs are that I'm looking for. So I'm going to say inside of the prompt message M or F. Please enter either one of those letters. And then I'm going to have to convert the string into a character. Right? Because remember, a character is different from a string because this can have multiple characters in it in a contiguous block versus a char, which is literally just one character at a time. So I'm going to have to say convert dot to char, and then I pass in that string input that hopefully only has one of the choices that I've presented, and then I'll store that in gender. Likewise, are you working? What do I expect the user to put in? I expect them to put in true or false. Why? Because I just want to do a direct conversion from the word true into the actual data type that is a bool, which is the keyword true. So for our visual presentation, true in quotation marks, that's what's coming in through the console.read line, but I need true, the keyword, which is what I would assign to a boolean, right? So we're going to do that convert dot to boolean, and I'm sure Visual Studio is giving you some good suggestions because it's contextually looking at what you're trying to assign this value to. So it would suggest to boolean because clearly you're working with a boolean. So this is it for prompting our user and for behind the scenes converting whatever they type from the default string into the actual data type that we need for our background processes. Using the correct data type is very important because if you needed to do math with the salary, you cannot do that kind of math with a string. So you have to have it as a numerical value to say, if this is what you earn per month, then this is your yearly salary, right? So if we ask them to enter your yearly salary and wanted to show them what they earn per month, we would have to get it as a number in order to do the math, right? So those are little things that you have to consider. So at the end of this, we want to print the information back to the user. So we want to print out, this is what you entered, here's what we have for you. So I'm just going to say console.writeLine. We know that we have to do that. Now, at this point, I can do what we call concatenation. So I'm going to say your name is. I have two choices. I can say your name is and then have another console.writeLine where I print out full name. Right? This is what we did last time. Right? But then that's going to end up doubling up every print statement when I can do it in one line. So your name is, and then I'm going to do what we call concatenation. So I'm going to say plus, and then give it the variable. So what this does is says, please add to this block of string. This is a literal because the programmer, typed this, so this will never change. Plus whatever came in through the variable because I don't know what the user is going to be writing in. All right. So that is what we're doing there. Another way to write this, or to do this kind of concatenation, let's say with age, if I wanted to say your age is, all right, I can actually put like a placeholder here. So I'm going to say open curly brace, 0, close curly brace. And then I'm going to put in the variable that matches. So I can say age, right? Now what this is doing is it's actually creating what you call args. So, or arguments that will be passed into the function. So the arguments will be bound to the variables that go in the same order. So if I had multiple arguments or multiple variables I needed to print, I could actually just do 1, 2, and then I can say some text here because I'm writing out a whole sentence, but parts of it need to be dynamic. And then for each of these, I'm going to call them placeholders. I would provide a variable in the same order. So 0 always comes first. The first variable matches to 0. The second variable matches to the other one, etc., etc. Right? So I would just list out as many variables as I have placeholders. So that's another one. So I'm going to keep this one simple, and we're just going to say your age is, and then we're using placeholder and printing age. All right. Another way to print or what we call concatenate string would be to say your salary is, and then I would put the variable here. So instead of saying placeholder, I would say curly brace and then put in the variable, so salary. But notice that everything is still orange or in the same color as whatever your string literal representation is. What's missing here is the $sign. So I need a $sign before I write the string, and then that allows me to use curly braces and superimpose the variable anywhere in that string that I want. This is called interpolation. So this is concatenation and this is called interpolation. So the thing with interpolation now is that inside of this string, it's very similar to using the args, but I can actually just print the variables wherever. So if I write some text and then I wanted another variable and then more text, so I'm just writing out one block of string, but anywhere I need it to be dynamic, I just write in that variable accordingly. So when it prints that string, it will just put in those values wherever I stated the variable should be. All right. So I'm leaving little comments so you're aware of what's happening at each point, right? So these are all of your options when it comes to printing and interacting with a string and variables, right? And C# does a good job of changing everything to string. So you have to be deliberate to change this into whatever data type, because it's coming from string. You have to be deliberate with the data type you're converting to. However, you would notice that I'm not converting anything else to string here. This is a string, and I'm putting in a double inside of a block of string. The same thing here with age, and well, full name is already a string. So here it will always convert whatever data type it is into string without you having to do anything else. But if you needed to, you could always say variable dot to string, which will also convert it to string. So that works, but that's kind of redundant because it's not needed because C# is that good, right? So I'm just showing you your options. So let me just duplicate this and say your gender is, and then I can just put in gender, and then I can say you are employed. Are you employed, or you are employed? Sorry, I'm just getting caught up in how to write this. You are employed, and then I'll just say working. All right, so it will automatically convert it from bool to string for me. A lot of the times you'll see me doing this, but later on we'll look at string manipulation in a bit more detail. So I'm just showing you some options here for us to get through this activity. Later on we'll delve more into what is possible when it comes to strings and different data types. So from here, if I want to run this application, once again, I have to change it to the project that we're working with, variables and data types, and then let me execute. And then let's start filling this out. So this is going to be test name, enter your age. Let's say 23. What is your salary? Let us say I am earning that 0.35. What is my gender? I'm going to state the ones that I was suggested to state. And then am I working? I am working. True. So at the end of it, you're getting your name, your age, your salary, your gender, and you are employed. Now notice there is no space here. Why is there no space there? Because I have a typo. So I can just fix that typo and that would fix that printout. But that is really all that I want us to go through in this exercise. We looked at the different variables and the different variable types and how we can give them default values versus non-default values. We also looked at the fact that we can or we need to, when accepting input from the console, convert to our specific data type based on what we need. And we also looked at the different ways that we can handle printing out static text combined with text coming in from our variable. In this lesson, we're going to be looking at math operators. So let us create a new project, and we're going to be calling this one math operators using .NET 6, and then we can get this show started. Now, we want to look at maybe 3 categories. We have basic operators, or basic assignment operator, rather. We have arithmetic operators and operations, all right? And then we have maybe compound assignment operators, all right? So we kind of looked at the assignment operator before. This one has to do with assigning a value. So int num, we have a variable. Cool. I want to give it a value. I'm going to say num is equal to maybe 5. That is called an assignment. So in regular English or regular math, as a human being, when you see the equal sign, it means that whatever is on the left has the same value as whatever is on the right. However, in programming, when you see one equal sign, it means whatever is on the right is being assigned to what is on the left. So this is our variable, and we're assigning the numeral 5 to the variable. So that means the reverse won't be true. If I write this in code, I'm just going to get an error because there's no way I'm saying that these two are equivalent. In regular English or regular human language, that would probably be acceptable, but not in programming, right? So I already explored how we assign values to our variables. And if we want to do it in one line, we can easily just say int num is equal to that value by default. So once the variable is created, it's created with that value. Now let's look at arithmetic operations. Now, arithmetic operations would have to do with us doing math. So I'm going to do num1. Let's give it a value of something random, 11. And num2, let's give it a value of 12. Thank you, Visual Studio. And you see here, it's a gift that keeps on giving. However, that's not what I want this time. So when we want to do math, we have the opportunity to do the same kind of math that we're used to in our regular daily lives, right? So if I want to do addition, remember I said that you can do different operations. We can easily add num1 plus num2, right? Simple math. So if I ask somebody, if I wrote a program for a calculator, and that's a nice activity for you, write an application that accepts 2 numbers and performs addition. You would ask them to enter into num1, enter into num2, and then you'd say num1 plus num2, and then probably have another variable, int sum is equal to num1 plus num2. Math is that simple, right? So I'm just going to write them inside of these console write line lines, so we actually print them back to screen and use fewer lines of code, right? So that's a nice activity. If you want to go and write a calculator after this activity, then that would be a good bit of practice for you, writing input, output, and processing applications. So we can do math, we can do addition, we can do subtraction, right? So instead of a plus sign, we have a minus sign. We can do multiplication. So remember that I'm just duplicating the lines using Control D on my keyboard or Control CV. All right. So multiplication is represented by the asterisk, not by the X. All right. So we write an X when we're doing math, but it's an asterisk in programming. Division, you don't have a division symbol on your keyboard. If you wanted that in Microsoft Word, that's a special symbol. So we use the slash, right? So that's a division sign. So num1 is being divided by num2. If we want to do modulus, we use the percentage sign, right? So modulus is basically the division or the remainder after division. So let's say 2 divided by 3. 2 divided by 3 is going to give you something like, okay, I'm sorry, let me say 5 divided by 2. Let me do something more easy. So 5 divided by 2 would go into it 2 times remainder 1, right? Because you would get, well, that's 2.5, but you would get 2 times remainder 1, right? 2 times remainder 1. All right. Now, if you wanted that remainder 1 only, then you would say 5 modulus 2, right? That will return just the remainder, right? That's what modulus does. So if you've never interacted with modulus before, that's what it does. So if you ever get an application where you need to find all of the odd numbers or put in a number and find out if it's odd, then pretty much if the number, let's say, I'm sorry, I think that would be a nice activity for us to do after this, so I'm going to leave that until later on. But if you ever have to find out if something is an odd number, all you have to do is do number modulus 2, and if whatever the result is 1, then it is an odd number, right? That's how modulus works. So let us, in a bit, just to drive the point home, I'm going to modify the value of num1. So I'm going to say num1, your new value is num1 plus 4. All right, so that's me increasing the value of num1. And then if we were to print out all of these, and I'll just add 1 here to say new value of num1 is whatever num1 now has. Afterwards, then you'll see that these were the original answers. I modified the variables value, and then we get these new values afterwards, right? So that's just simple math operations, right? And then you have different libraries that allow you to do more complex operations like tangent and sine and cosine, etc. But I'm not getting into those in the basics right now. So if I run this program, once again, change the startup project to math operations or operators, start the project, it should just spit out all of these calculations to the console screen. And there we go. So sometimes the console will pause. You just have to click. If you click in it, it will kind of pause. So when you press enter, it will continue, right? So here we have the addition, the subtraction, multiplication, division, the modulus, right? So you see here, it said that 12 could not go into 11, right? Or what was that? That was num1, that's 11 divided by 12. So that's 0 times. However, the modulus is 11 because the remainder would be 11, right? So then we go on to new value of num1 is 15, and then we get the addition, we get the subtraction, we got the multiplication. Now, 12 into 15 goes 1 time, and the remainder is 3. So modulus gives us the remainder, all right? So that's really it for basic arithmetic operations. Now, compound assignment operators would be like a shortened version of doing something like this. So if I wanted to modify the value of a variable, but I wanted to like add or subtract from the original value, right? So in this case, I increased it by 4. So I said, whatever the value of num1 is right now, give it back to me and add 4, and then assign that new value to num1. So that is how I would increase it. If I wanted to decrease it, I would just do the same with a minus sign, etc. Right? If I wanted to make it 4 times its original value, I'd say multiply. Now, when we talk about compound assignments, it would be a shortened version of doing this kind of operation. So if I wanted to say increase num1 by 4, I can say num1 plus equal, and then give it the value. So this would now say accumulate. So we have this is called an accumulator, right? Num1, increase yourself by 4. That's pretty much the same thing as writing what we did up top here. I'll just comment that out. All right. Same dynamic. All right. And then based on what you want to do, like I said, if you wanted to decrease by 4, it would be the same as saying num1 minus 4. If you wanted to multiply it or, make it 4 times its original value, then it would be times, right? If you wanted to make it 4 times less than its original value, then it would be divide, etc. So when we talk about compound operations, that's what we are doing, right? Compound assignment operations. So the thing is that with each of these operations, we're actually changing the value of num1. So it's not a matter of us just printing out, this is the result of the operation. It is actually changing. So here I'm saying add 4 to, and remember sequence. So num1 starts off as 11. We go through all of this. We're just printing out the result of the operation. We're not assigning anything. We're not making any new variables or assigning any value to any variable. Then I say increase num1 by 4 and make that the new value. So now num1 at this point is no longer 11. It's now 15. So all of these math operations are relative to num1 being 15 and num2 still only being 12, which is why we saw the different set of results. At this point, num1 is still 15. So when I say plus equal 4, I am now increasing it from 15 to 19. Because at this point, it is already 15. So I'm adding 4 to 15. And then here, I'm going to say make it back 15. Right? Here, I'm going to say 15 times 4, which is equal to 60. So now num1 has a value of 60. And then here I'm going to say divided by 4. I'm putting it back to 15. And then I'm going to say modulus 4. So that means 15 modulus 4 would be, if my math serves me right, 3. So what we're going to do, just to test if my math is still on point, I am going to do a console.writeLine, and I'm going to be printing the value of num1 with each operation, right? And then we can compare to see if my math that I have in the comments there would be correct. All right, so let us run this application again. All right, so now it's your time to mark my math assignment. So I did say that the first one, the outcome would be 19. There we go. The second one, the outcome would be 15, then 60, then back to 15, and then the modulus would be 3. So now each time we're changing the value of num1. Right, so that is how you can go ahead and modify variables. If I said increase all the prices by 5, then you can just say price times equal 5. It would automatically do that.